This is the Almost Time in the Newsletter for the week of August 6th, 2023. Content authenticity statement: 100% of this newsletter was generated by me, the human. When I use AI to generate content, I will prominently label it. This is important because AI output cannot be copyrighted, and therefore this disclosure, which you might want to do for yourself, reinforces my copyright claim over my material, over the material that I actually create. It reminds people, yeah, it's copyrighted. What's on my mind this week? The fallacy of the single AI. What's the biggest blind spot people have about generative artificial intelligence and its capabilities, its capacities? Beyond, fanciful science fiction predictions that don't really have a basis in reality. No Skynet, sorry, not yet. The biggest blind spot most people have about artificial intelligence, at least currently, is the fallacy of the single intelligence. Here's what this means. The power of generative AI becomes apparent as complexity increases. The first generative AI models were fairly limited in capabilities because they were trained on such little data. As companies like Google and OpenAI added more data, more capabilities of these models began to emerge. The ability to answer more complex questions, solve more complex problems, take on tasks that previously AI models had no chance of achieving. This created a natural eagerness to build bigger and bigger models, something we see when people talk about AI models and how many parameters they have. 7 billion parameters, 30 billion parameters, 70 billion parameters, and the number of tokens they trained it on, 100 billion tokens, 5 billion tokens, 1 trillion tokens. The natural assumption is that a bigger model is a better model, and to a great degree so far, this has proven true. GPT 3.5 was an improvement on GPT 3. GPT 4 is an improvement on GPT 3.5. When OpenAI's GPT 5 comes out, there'll be an improvement on 4. The newest version of any model generally has more tokens and more parameters and more training time than its predecessor. So it seems natural that people would always assume bigger is better, and that whatever problem we're facing can be solved by making models bigger. And we have ample precedent for this assumption. We saw it during the chip wars when companies like Intel and AMD kept making faster and faster CPUs, touting each other's chip speeds as better than the last. Shows you my gray hair. I remember long ago when Intel earned massive bragging rights for reaching a consumer chip speed of 1 gigahertz back in March of 2000. The 1 gigahertz Pentium. You would think, based on that example, we would have something like 23 gigahertz computers today, but we do not. In the case of CPUs, we ran into literal limits of physics that prevented us from making chips that operated much beyond 4 gigahertz. For example, the faster a chip goes, the more heat it generates, and the harder it is to keep synchronized across billions of operations. Heat is actually the single biggest problem with CPUs. We are running into similar limitations with large language models and generative AI. The bigger a model is, the more compute power it's needed to make it and operate it. Think of it like manufacturing bigger and bigger cars, right? Not only does the assembly line need to be bigger and consume more resources, so does the final product once it's built. Yes, a bigger model in general delivers better quality than a smaller model, but we are running into real resource limitations for bigger models. Anyone who's logged into a system like ChatGPT has seen issues with speed and quality. In fact, on last week's podcast, we noted that ChatGPT's premier model, the GPT-4 model, appears to have gotten dumber over time. That's why the fallacy of the single intelligence is problematic. The assumption that bigger is better will lead people to chase after bigger numbers and bigger models. And the parallel assumption is that bigger models also mean more and more capabilities, more abilities for models to do ever more complicated tasks. What happened with computers once we started hitting physical limits of computing power? The industry pivoted from making faster chips to making more of them bundled together. You started to see companies advertising they had 2 cores, 4 cores, 6 cores. My Apple computer, my MacBook, today Apple advertises as having a 12-core CPU and 32-core neural engine as a way to suggest the total processing power of the system. And that evolution from one big chip to a bundle of chips is what the evolution of generative AI will look like as well. In general, nature addresses complex problems with complex solutions involving many parts rather than a bigger part, right? One animal's survival is not guaranteed, but having a pack of animals greatly increases the survival capabilities of every animal in the pack. We do the same thing. Think about it. Can one employee power an entire company, or do we hire many people? The latter, of course, we hire many people. That's where generative AI is already going. Instead of trying to make bigger, more magical single models that can do everything, We are seeing more architectures of model ensembles, collections of models chained together to accomplish tasks. Fable Studios, I talked about this recently, showed this off very capably in their recent South Park generative episode. They didn't try to force one model to do everything. Instead, they built an ensemble of different models that did different tasks, and each of those individual tasks got sewn together with some infrastructure. So what? Why do we care? Why is this any of important to the many folks who just want to use AI to solve problems? Well, it's important to understand because it frames how we need to think about problems and the AI solutions we will commission to solve those problems. What we're seeing with agent networks, ensembles of AI models, is that they're very capable of taking a complex task, breaking it down to much smaller tasks, and then using individual models to solve those specific smaller tasks. That's no different than how we humans solve problems, right? We take a big task like achieve profitability, and we break it down into smaller tasks like marketing, lead generation, deal management, etc., until we pile up, close sales, and achieve our goal. Right now, many AI companies are little more than a skin or a wrapper on someone else's model, usually with a pretty interface to make things easier to understand or with specific prompts under the hood to generate certain outputs. But this class of companies is going to go away fairly quickly. Those companies that survive and prosper, they will have ensembles of models put together in very specific ways to achieve results that exceed what any individual model is capable of alone. And that's where the magic will happen, where companies will differentiate themselves. When you have, one gigantic all-purpose, super model, there's really no opportunity for users of those models to differentiate, to show any kind of uniqueness, right? If you take two people who are equally competent at prompt engineering and have them use such a megalithic system, one person's probably not going to achieve substantially greater results than another. When you have ensembled systems, you can achieve significant differentiation because the models you choose under the hood and the way you connect them together will dictate the results you get. Here's how. Suppose we're going to cook dinner, and you had one super appliance that did a bunch of things reasonably well, like every appliance manufacturer often touts 13 appliances in one. It fries, it bakes, it broils, it makes soup, We know those appliances can do many of those things, though not necessarily equally well. In that case, the appliance would not be a differentiator for quality, for food quality, because everyone would be using the same thing, and probably would also be crazy expensive. Now, suppose you have a kitchen full of different appliances, a great blender, a nice induction stove, a deep fryer. Instead of cooking everything in one machine, you'd use different machines for different capabilities and in different orders. For example, you probably would not use a blender for steak, and you absolutely would want to use a blender to mix the gravy for a steak or a roast. You probably would not want to use a deep fryer for soup, but you could absolutely use a deep fryer to make shrimp tempura that you put into an udon noodle soup. The network of appliances in a kitchen creates more powerful outcomes than one single super appliance. Likewise, a network of AI models will create more powerful outcomes than one single super model. As end users of AI, we will probably care very little about what the underlying architecture of systems are, so as long as we get the results we want. But as economics begins to take hold, as we begin to hit practical limits of compute power, electricity, cost of systems, ensembled systems will be the way we continue to expand the power of generative AI, just as we have done with computer CPUs today. And this change in strategy will let us keep growing the power of AI over time. As consumers of AI, particularly for working with vendors that we're paying money to, understanding what's under the hood will help us understand the value we're getting and how current a vendor can stay with the latest technologies. This is really important. For example, if a company's technology is predicated on one single big super model like GPT-4, then what tends to happen is that company gets locked into that specific model. The next time something newer and better comes along, it can be challenging for the company to change the model in the same way that it's mechanically very challenging to rip one motor out of a car and put a totally different motor in, right? You take a motor out of a Prius, you can't really put in a Ford F-150 motor into that vehicle. It just doesn't work. If you're building on ensembled models, particularly if you've been clever and smart and built an abstraction layer in, then when something new comes along, you don't have to start from scratch. You can swap out the affected pieces while leaving the rest of the system intact, just like you can buy a new blender for your kitchen without it affecting your stove or your microwave. That kind of agility is what you and I want to look for in our AI vendors, the agility to change with the ever-increasing pace of change in AI. Whether you're buying technology from someone else or building it yourself, consider how the technology is evolving and then decide whether you want to pursue or purchase systems based on one big model or a network of models. I would wager the second choice is probably the one you want to go with. All right, let's see what else is happening this week. Besides all the courses and things I'm promoting and stuff, by the way, be sure to check out the new ebook and the new keynote. It's at the top of the newsletter. This week has stuff on content statements, why they're important, zero-click SEO futures, the takeaways from Macon. Also, this week while I was out and about, John and Katie covered how to be a good podcast host, so that was worth. Well, we also did a show on preparing for fine-tuning AI models. In fact, go check that one out. That was good. If you have not seen the keynote from Macon, go see it. And if you'd like that talk at your company, we have that available. Let's talk about jobs. In jobs this week, Adobe at Implementation Engineer at Shift Labs, Director of Marketing at Let's Roam, Head of Marketing at Rizobacter, Lead Data Engineer at CarWow, Marketing Director at Wade Marketing, Product Marketing Director at Cast AI, Product Marketing Director at Viva Systems, Regional Commercial Director at Ravago, User Researcher at CarWow. So lots of wow on the CarWow. In other news, we have Meta's AI personas launching next month. We have viral TikTok trends, Women's World Cup marketing campaigns. We've got SEO competitive analysis, a new Chrome extension by All-in-One SEO to evaluate your SEO in a single click. We have OpenAI filing a trademark application for GPT-5. So they are getting ready for the next big one. We have stuff on tipping points in tipping points in plant genetics. State Farm using influencers to attract Gen Z to their video game. I don't know what that's all about, but I guess we'll find out. How IBM is using the Chief Data Office to improve data quality. We also have some stuff on, what is this? Climate-resistant barley. That sounds pretty interesting. And AI brain implants restoring a paralyzed man's movements and sensations. Pretty cool stuff. Upcoming events, ISBM in Chicago, followed by Content Marketing World, Marketing Analytics and Data Science, Content Jam, Marketing Props, B2B Forum, and Social Media Marketing World. So lots of events coming up. Going to be on the road quite a bit. So that's all the news for this week. Thank you for tuning in. However it is you consume this, I appreciate you being here, and I'll talk to you next time. Take care. If you like this video, go ahead and hit that subscribe button.